All right. The last part is somewhat a little bit more uh, sophisticated and longer and uh, probably more tedious. So I decided to split it like into a different video. All right. So so here we have a function of three variables, and we need to find all partial derivatives with respect to x, y, and z. So notice that here we have the expression of this type, like some expression um, raised to the power of another expression, right? So, I mean, it looks like, I don't know, f raised to the power of g. So in order to simplify that, basically we need to convert it to a logarithmic form, right? So how do we do that? So logarithm of f raised to the power of g is really, when you take the logarithm of something, then the power, the exponent is factored out. So that this is really g ln f. So which means that uh, f to the power g itself is really e to the power g ln f, right? So, and this is how we can simplify it, right? So our my f of x, y, z is really just e to the power x plus y um, logarithm. Well, I think it's probably better to write it like this: y z times logarithm of x plus z tangent x. Okay, so now what is the partial derivative with respect to x? So we need to differentiate um, the exponential function first. The derivative of the exponential function is the function itself, so e to the y z times ln of x plus y times the derivative of the exponent, so which is yz is now a constant, so I guess it's just yz divided by x plus y plus z tangent x. We are differentiating with respect to z, so z is a constant, and the derivative of tangent x is 1 over cosine square x. So it's just z divided by cosine square x. If you want, you can write it as secant x, secant square x, but I personally I don't like secant, so I always write 1 over cosine x. All right, so now f y is going to be, so we've got to differentiate our exponential function with respect to y now, right? So first, the derivative of the exponential function is the exponential function itself. So yz times ln of x plus y times the derivative of the exponent. And now the exponent is the product y times ln of x plus y. And z is sort of can be factored out, right? So z is now a constant, so we can factor it out. And now we've got to differentiate the product. So the derivative of y is just 1. So this is ln of x plus y plus y divided by the derivative of ln of x plus y is 1 over x plus y. Okay, so plus z tangent x does not have y, so we just don't differentiate it. And finally we have z, so the partial derivative of f with respect to z is going to be, and again, so we've got to differentiate our big exponential function is e to the y z times ln of x plus y times the derivative of that with respect to z, and it's kind of a bit easier, so it's just y times ln of x plus y plus z tangent x is derivative with respect to z. Now tangent x is a constant, so it's just x. Well, now if you want, you can really replace, this in all the three um, expressions with x plus y raised to the power yz, but I don't know. You don't have to really. It's just whatever you prefer. So because very often it's actually easier to work with whatever you want to do. I mean, if finding partial derivatives is not your end goal, if you want to do later something with them, then it's probably better to keep it in this logarithmic form.